Okay, so this is where we left off, where we were saying we found the integral x squared over 2, and if you plug in 2 for x, you get 2 squared equals 4 divided by 2 equals 2, which is the same area we got when we just did the geometric formula with the triangle. So what this means is that if you have the formula for a line, and you take the integral, you get the area under the line. So if we went from 0 to 2, we would integrate 0 to 2. And that would give us the area under the line from x equals 0 to x equals 2. Okay, so if you have a slope of 1, you do an integral, you get the formula for the line. So the proof of this is the slope of y equals x is 1, so the slope of dy dx over dx dx is just 1. Right. So if you have the line, you do the integral, you get the area. If you have the slope and you do the integral, you get the line. So if I have the area and I do the derivative, what do I get? Because the derivative is the opposite of the integral. So if I have line integral to area, then I have area derivative to line. And if I have line derivative, gets me slope. So the reality is that sometimes the slope will be a line of itself, and you actually can find the slope of the slope, right? Which is like acceleration to velocity is like the same thing, where you have x, and then you go the change with respect to time is change in x over change in time, right? So what you have is meters per second. X is distance, change in time is seconds. So meters per second is velocity, which is the slope of distance. So the area under the line of the velocity is actually the distance. So if we have the velocity, and we do, and it's, which is, we take the derivative again, we have dv dt. So v is meters per second, so you have dt is the change is 1 over s. So what you actually get is you get meters per second squared, which is the acceleration. So the slope of velocity is acceleration. The area underneath the curve of the acceleration is the velocity. The area underneath the curve of the velocity is the distance. Okay, so I'm going to try to do this whole thing. I haven't done this in a while, but I think that I can do it. We're going to start with the area, where the distance x is just equal to the initial position. Right. So if you want, so the x is like the top, so if you do the derivative, you do d dt, which is dx dt, is equal to dx naught dt, and this is velocity. So what you do when you're what this is you know, the velocity is equal to, what is this, the initial velocity. So that makes sense, right? So we're getting the same answer on both sides, obviously, because it's just x and x. So that's like very basic. You can see how you can go, you know, kind of